Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are starting exercise number 1.3. So in the last video we have discussed about quantifiers. Two types of quantifiers are there. Which are these two quantifiers? One is existential quantifier, which is denoted by this notation and it is read as what? There exist. And second quantifier is universal quantifier, which is denoted by this notation, and this notation is read as what? For every or for all. Using these quantifiers we are solving first example. So in the question number first, we have to find out the truth value of the following statement, and this truth value we have to find out using the element of this set. So observe, the element of set A are 3, 5, 7, 9, 11 and what? 12. Now let us check whether these statements are true or false for the element of set A. So observe the first example. Here it is given to us that there exists x belongs to A. There exists means what? There exists at least one element which satisfies the condition in the given example. That we have to check. Means at least one element is satisfying, we can say that statement is what? True. So hope you are getting it. There exists means there exists at least one element which satisfies this condition. If no element is satisfying this condition, at that time we can say that it is false. Now see the first example. So there exists x belongs to A such that x minus 8 will be equals to what? 1. So we know that from which element 8 should be subtracted to get 1. So definitely 9. 9 minus 8 is what? 1. Let us check whether 9 belongs to this set or not. Yes, 9 belongs to this set, means there exists at least one element which satisfies this condition. That's why we can say that the statement is true. The statement is true for x is equals to, for which element it is true? For x is equals to 9 belongs to A. So that's why we can say that therefore truth value is T. Now let us try to solve the second example. So observe the second example. For every x belongings to A, x square plus x is an even number. Means square of the number and addition of square of the number and number itself is an even number. Let us check whether this condition is satisfying by what? For every. Means if every element satisfies this condition, at that time only we can say that it is true. If at least one element is not satisfying, then we can say that it is what? False. Because which notation is used here? For every or for all. So now 3 square is what? 9. 9 plus 3. 9 plus 3 is what? 12. So it is even. So see, for every element, either it is even number or it is odd number, the square of the number and addition of that number with itself is always what? Even. Either it is even or odd. So in case of 3, already we have seen that this value is even. Let us check for 5. What is square of 5? 25. 25 plus 5 is what? 30. 30 is even number. In the same way, we are able to show that for every number, this addition is even. So since every element satisfies this condition, that's why we can say that this statement is true. So this statement is true for every x belongings to A. So therefore truth value is T. So in this way we have got the truth value. Now third statement is there exists x belongings to A such that x square is what? Negative. And easily we can observe that square of every element in this set cannot be negative, isn't it? Square of 3 is also 9, square of 5 is also what? 25. Means squares of every element in set A is positive, but here they are saying that there exists at least one element in this set whose square is negative, which is not possible. That's why we can say that this statement is false. So this statement is false for every x belongings to A. Therefore truth value is F. Now let us try to solve the next example. For every x belongings to A, x is even number. So check that every element of this set is even. They are saying that every element, for every x belongings to A, x is even. So we can observe that here 3, 5, 7, 9, 11 are what? Odd number. But this statement says that every element of this set is even. So which is not true. So that's why we can say that this statement is false. For which element it is for? For x is equals to 3, 5, 7, 9, 11. For these element in the set A, the statement is false. Now observe the next example. In the next example, what is the statement? There exists x belongings to A such that 3x plus 8 is greater than what? 40. So here we can observe that definitely this condition is not satisfying for 3, 5 and 7, because square 7 into 3 is what? 21. 21 plus 8 will be 29, which is less than 40, but we have to check the element which satisfies this condition, means such element whose value is what? Greater than 40. So if we are considering here 9 3s are 27, 27 plus 8 is 35, which is also not greater than what? 40. Now check for 11 3s are 33, 33 plus 8 is 41, so 41 is greater than what? 40, means for 11 this condition is satisfying, means definitely for 12 also this condition will get satisfied. So we can say that this statement is true for x is equals to 11 and 12. So this statement is true for x is equals to 11 and 12 belongings to A. So therefore truth value is T. Now observe the next statement. In the next example, what we have to check? For every x belongings to A, 2x plus 9 is greater than what? 14 or not. For every, means we have to check whether every element satisfies this condition or not. So if we are considering first element 3 into 2 is 6. 6 plus 9 will be 15, and 15 is greater than what? 14. For x is equals to 3, if this condition is satisfying, means definitely for the numbers greater than 3 will also this condition will get satisfied. That's why we can say that this statement is true. It's true for every x belongings to A, and that's why we can say that truth value is T. In this way, we have completed all the example from question number first. Now let us try to solve the question number 2, in which we have to find out dual of the given compound statement. Why we are saying that it is compound statement? Because in this statement one or more logical connective appears. Such statements are called as what? Compound statement. Only 6 rules we have to follow to find out the dual of the given compound statement. So observe that these rules already we have discussed on it. Just simply replace and by what? Or. Replace or by and. Capital T means true, replace it by capital F, replace capital F by capital T, small t means tautology by small c by contradiction, and small c we have to replace it by what? Small t. Only these 6 rules are there to find out dual of the given compound statement. So applying these rules, let us try to solve the first example. So here statements, 10 examples are given in our textbook, and I have prepared one table on front side, means on this side we are finding dual of the given compound statement. So observe the first statement. So we are not disturbing to later, we are not disturbing to brackets also. Only we have to use this rule. If and appears, replace it by or by and, t by f by t, small t by small c and small c by small t. So P, keep it as it is. Or appears, so replace it by and. Don't disturb to bracket, don't disturb to letters also. And appears, so our rule says that replace and by what? Or. R, keep it as it is. So in this way we have got the dual of this statement, only or and appears. So we have replaced or by and by what? Or. So use the same method to solve the remaining example. So here P, keep it as it is, and will get replaced by or. Q, again and will get replaced by what? Or. So in this way find out the dual. So here also in the first bracket or is there, replace or by and. So here we will get P and Q, again and appears, so replace it by or. In this bracket or appears, so replace it by and. So R and S. So observe the next example. So P, keep it as it is, and will get replaced by or negation Q as it is. There is no rules for negation, only and will get replaced by what? Or here. Observe the next example. In the first bracket or is there, so I am replacing that or by and. So here negation P and Q. Again here and is there, so this and will get replaced by or, and here or is there, sorry, and is there, again this and will get replaced by or, means here we will get negation R or S. Now observe the next statement. So here negation P, keep it as it is, negation P as it is, and will get replaced by what? Or. Again here negation Q as it is, and replace this AND by OR. Negation Q OR. Again in this bracket OR is there, and OR will get replaced by what? AND. So here we will get P and Q. Again this AND will get replaced by OR negation R. So observe the next statement. In the next statement, keep this square bracket as it is, this negation also as it is, square bracket negation as it is. So here P or Q is there, so OR will get replaced by what? And according to our rules of duality, means while finding dual we have to follow these rules. Sorry, this AND will get replaced by what? OR. And will get replaced by OR. Keep this square bracket as it is, P also as it is. Again this OR will get replaced by AND. Negation bracket Q also as it is, negation and in bracket Q as it is. So this AND will get replaced by OR negation S. In this way we have got the dual of this statement also. Observe the next statement. Small c will get replaced by what? Small t, means contradiction will get replaced by tautology. So here or will get replaced by what? And. जनरली क्या होता है कि हम इसे लेटर ही कंसीडर करते हैं. जस्ट सिंपली ऑब्जर्व दैट इफ टी appears or c appears, so don't consider it as later. Small c means contradiction and small t means what? Tautology. So if small t appears, replace it by c, and small c appears, replace it by t. बच्चों की यही पे गलतियां होती है कि वो उसे लेटर या भूल जाते हैं, उसके तरफ ध्यान नहीं रहता, सिर्फ एंड और कैपिटल टी कैपिटल एफ की तरफ ही ध्यान रहता है. So observe the given statement very carefully. So if c appears, replace it by t, and if t appears, replace it by c. Now here curly bracket, keep it as it is, P also as it is. This AND will get replaced by what? OR. In this bracket Q or R is there, so this OR will get replaced by what? AND. Close the curly bracket. Observe the next statement. Here negation P, keep it as it is, and this OR will get replaced by AND. Negation P and in this bracket Q and R is there, so here we will get Q or R. And t, and will get replaced by OR, and the small t will get replaced by what? Small c, means tautology will get replaced by contradiction. Observe the last statement. So here P or Q is there, so OR will get replaced by what? And. Again this OR will get replaced by and small c will get replaced by what? Small t. So these examples are very easy. Only we have to follow these 6 rules while finding dual of the given compound statement. Simply replace AND by or by AND. Capital T by capital F by capital T, and small t by small c, and small c by small t. In this way we have completed all the example from question number 2. Now let us try to solve the question number 3. In this question we are finding negation of the given statement. Whenever we are finding negation of the given statement, we have to use rules of negation, which already we have discussed in the last video. So using these rules of negation, let us try to find out negation of the first statement. If you'll observe first statement, here 2 parts are connected by what? Or means what? Disjunction. So we have to use this rule. So what rules we have seen? Whenever we are applying negation on the bracket, replace every letter by its negation, and by or by and. See what we'll get if we are using not in this first part. So here what is the statement? X plus 8 is greater than 11. So it will become x plus 8 is not greater than 11. And according to rule, or will get replaced by what? And use not in the second part also. Here second part is what? Q. Use negation in the Q. So negation means what? Not. So y minus 3 is equal to 6. So its negation will become y minus 3 is not equal to 6. So in this way we have got the negation of this statement, or you are able to write it in this form also, x plus 8. Now here not greater than 11. Not greater than means what? Either less or equal to 11. Not greater. Greater नहीं होना चाहिए, तो फिर equal भी हो सकता है या तो less हो सकता है. So you are able to represent your answer in this form also. Y minus 3 is not equal to 6. So you are able to give the answer in any one of these 2 forms. Now observe the second statement. Here 2 parts are connected by and, means and will get replaced by or, and both the statement will get replaced by what? Negation according to this rules of negation. So this is first statement, replace it by its negation. X is less than 15 will become what? X is not less than 15, and will get replaced by, or use negation in the second part. 25 is greater than 20 means it will become 25 is not greater than what? 20. So in this way we have got the negation. Again, this answer can also be written in another form also. Observe here, X is not less than 15. Not less than means either greater or equal to 15. Or keep it as it is, 25 is not greater than 20. Not greater than means maybe less or maybe equal to 20. In this way we have got the negation of this statement. We are able to write down our answer in these two different forms. Observe the third question. So in the third example, what is given? Quadrilateral is a square if and only if it is a rhombus. It means what? Quadrilateral. It is used for what? Quadrilateral. So consider this first part as P and second part as what? Q. And these two parts are connected by which logical connective? If and only if. And what is the negation of P if and only if Q? P if and only if Q is P and negation Q or Q and negation P. So this symbolical representation, simply we have to convert it into verbal form. Means we have to replace P. P means what? Quadrilateral is a square, and replace Q by what? Q means what? Quadrilateral is a rhombus. Using that rules of negation, now we are finding negation of this statement. Means simply we are converting this symbolic form. Already negation of P if and only if Q is known to us, only we have to convert symbolic form into verbal form. Now P, observe the first bracket, P or negation Q. P means what? Quadrilateral. Quadrilateral is a square. Is a square, and can be replaced by what? But. Negation Q. Q means what? It is a rhombus. Negation Q means it is not a rhombus. It is not rhombus. Or what is the second part? Q and negation P. Q means what? It is rhombus. It means what? Quadrilateral. Or quadrilateral is a rhombus. Rhombus and negation P. And means what? But. And P means what? Quadrilateral is a square, so its negation means what? Quadrilateral is not a square, so it is not a square. It is not square. Instead of writing quadrilateral, just quadrilateral we are writing, representing here by what? It. So in this way we have got the negation of this statement, P and negation Q, or Q and negation P. But means what? And means quadrilateral is a square but it is not a rhombus, or a quadrilateral is a rhombus but it is not a square. In this way, using rules of negation, we are finding negation of P if and only if Q, or negation of every statement. Now see the example number 4th. It is cold and raining, means two parts are connected by and. So, and we are finding negation of this conjunction. What is this negation? Negation P or negation Q, means this first part also use not, and in second part also use not, and will get replaced by what? Or. What is the first part? It is cold. So what we will get here? It is not cold, and will get replaced by or, and it is not raining. It is not raining, means in the second part also we have to use not. It is not cold or it is not raining. In this way we have got the negation using rules of negation. So observe the next part. If it is rain, then we will go and play football. So here after if, whatever may be the part is there denoted by P, and after then whatever may be the part is there denoted by Q. Now observe this statement very carefully. First part is what? P. P, if then is there, means which logical connective, which symbolical representation we are using? Implication. In the second part, we will go and play football, means two parts are there. Let us denote this part by Q and this next part by R, and these two parts are connected by what? And. Q and R, means its symbolical representation will be this one, where P means what? It is raining. Q means what? We will go, and keep it as it is. R means what? Play football, means we will play football, isn't it? and we are finding negation of this statement. Whenever we are finding negation, we are using rules of negation. So here this rule of negation we have to apply here. So whenever we are finding negation of P implies Q, what is this negation? P and negation Q means P, keep it as it is, and negation Q means negation of this second part. This is the second part, so negation of Q and R, because instead of Q and R is there. So here negation of Q and R we will get according to this rule of negation, which is called as conditional law. P and keep it as it is, if we are applying negation on this bracket, so what will get? Negation Q and will get replaced by or and negation R, means using this rule of negation we will get negation P or negation Q. So here we will get negation Q and will get replaced by or negation R. Now we have to convert this symbolic form into verbal form to find out negation of this statement. Now P means what? It is raining. It is raining. It is raining, and means what? But negation Q means we will go, so we will not go. We will not go, or negation R means or we will not play football, because R is what? We will play football, so we will not play football. In this way, using rules of negation, we have got the negation of this implication. Now see the next example. Root 2 is a rational number, so its negation is root 2 is not a rational number. Root 2 is not a rational number. Now observe it very carefully. All natural numbers are whole number. Generally, while finding negation, what we are doing, all natural numbers are not whole number. So in this way, the statement will become wrong, means it is not logically right. So whenever the statement start with all or every, its negation start with what? Some or there exists. If we are writing its solution in terms of sum, then what result we will get? Some natural numbers are what? Not whole number. Not, because we are finding negation, means we have to use not whole numbers. In this way we are getting negation, means don't start with all will get replaced by some or there exists. Some natural numbers are not whole numbers. Getting it? If we are writing the answer in terms of there exists, then what result we will get? There exists at least one natural number which is not a whole number. In this way we have got the negation of this statement. Now observe the example number 8. In this example we have to find out the negation of for every n belongs to n square plus n plus 2 is divisible by 4. Means for every, statement is starting with what? For every. So in case of negation, for every we have to replace it by what? There exists. Means its negation will become there exists n belongs to n such that what is the second part? What is the statement? N square plus n is divisible by 4. So what we'll get here? N square plus n plus 2 is not divisible. Not, why not? Because we are finding negation, and the rules of negation says that replace for every by what? There exists. Means for every will get replaced by there exists, and use even negation also. Means n square plus n plus 2 is divisible by 4. In case of negation it will become what? Not divisible by 4. Same method we have to apply to find out negation of this last statement. Negation we have to find out negation of there exists x belongs to n such that x minus 17 is less than 20. So there exists will get replaced by what? For every x belongings to n, x minus 17 is less than will become what? Not less than 20. In this way we have seen how to find out the negation if the statement is what? Quantified statement. When we can say that statement is quantified, if quantifier is used in the statement, in this statement also quantifier is used, in this statement also quantifier is used, and we have seen how to find out the negation of the statement if the statement is what? Quantified statement. Now in the last question we are finding converse, inverse and contrapositive of the given conditional statement. Conditional statement means two parts are connected by what? Implication. Implication means what? If then. So if the statement is conditional statement, at that time its converse is, means converse of P implies Q is what? Q implies P. Inverse of this statement is negation P implies negation Q, and its contrapositive is negation Q implies negation P. If these symbolical representations are known to you, you are easily able to find out converse, inverse and contrapositive just by converting this symbolical representation into verbal representation. And from the given statement you will get the value of what? P and Q. Only you have to substitute the value of P and Q in this symbolic form and convert it into what? Verbal form. Observe the first statement. Here also two parts are connected by what? If then. This is first part, let us consider it as P, and this is second part, let us consider it as what? Q. Once P and Q are known to us, then converse. Converse means what? Q implies P. Q implies P. Whenever implication is there, start with what? If. Means if P then Q, isn't it? Conditional statement means what? It is connected by which logical connective? If then. So if x square is less than y square, then means if Q then P. P means what? X is less than y. Just simply we are converting this symbolic form into what? Verbal form. Now let us try to find out inverse. Inverse means what? Negation P implies negation Q. Means whatever may be the conditional statement is given to us, in both the part use what? Not. The new statement which you are getting, it's called as inverse of the given statement. Means whatever may be the statement is given to us, in both the part we are using what? Not. Means what we will get? If x is not less than y, less than will get replaced by what? Not less than. Then in the second part also use negation, means x square is not less than y square. In the given statement, in both the part, if you are using statement, it's called as what? Inverse of the given statement. Now lastly we are finding contrapositive. While finding contrapositive, whatever may be the converse statement is there, in both the part use what? Negation. New statement will be contrapositive of this given statement. Is it clear? So this is what? Converse. In this statement, in both the part use negation. Converse means what? Q implies P. So here negation Q, and here we will require what? Negation P. So here what result we will get then? If x square is less than, I am replacing by not less than because we are using negation in the first part. In the same way use the negation in the second part. So the new statement which you are getting is nothing but contrapositive of this given statement. In this way we are finding converse, inverse and contrapositive of the statement. Simply you have to remember this symbolical representation of converse, inverse and contrapositive. Remaining part is just to convert this symbolical representation into what? Verbal representation. P and Q you will get from the given statement. Now observe the second example. In the second example, what is the statement? A family becomes literate if women in it is literate. So directly this statement is not given in the form of if then, isn't it? So the statement does not start with if. And that's why we have to arrange this statement in the form of what? If then, in such a way that meaning does not changes. Again observe the given statement. A family becomes literate if the woman in it means what? It means family. It is used here for family, isn't it? So the woman in the family is literate. So if I am reading this statement in this form, if the woman in family is literate, then family becomes literate. At that time meaning does not changes, isn't it? Means part after P, if it's considered as P, and this part here we have to consider as what? Q, and here symbolical representation is what? P implies Q. Means if we are reading this statement in this form, if the woman in family is literate, then family becomes literate. So the meaning of this statement does not changes. Just we are trying to write down in this in the form of what? P implies Q. Once P and Q is known to us, easily we are able to find out its converse, inverse and contrapositive. What is its converse? Q implies P. Q means what? If a family becomes literate, then women in family is literate. Now let us try to find out inverse of this statement. Inverse means what? Negation P implies negation Q. This is P and this is Q. So we are connecting them by what? Implication. Implication means we have to start with if. Negation P means the woman in family is not literate. Just we are using what? Negation in this statement. Negation P implies means then. After then write down what? Negation Q. Negation Q means a family becomes not literate means illiterate. Now we are finding contrapositive. Contrapositive means negation Q implies negation P. This is what? Converse means Q implies P. Q implies P. In both the part, if we are using not, we will get what? Contrapositive. So what we'll get here? If a family becomes not literate, then again use not in the second part. So what we will get? Women in family can be replaced by it also. Then women in it is not literate. Women in it is not literate. In this way we have got converse, inverse and contrapositive of this statement. Now see the third example. What is the given conditional statement? If surface area decreases, then the pressure increases. The part after if we are considering it as P, and after then we are considering it as what? Q. So using this, now we are finding converse. Q implies P. Q implies P means what? If pressure increases, then surface area decreases. In this way we have got its converse. Now whatever maybe the statement is given to us, use negation in the both part to find out its inverse. So this statement is given to us in both the part, we are using what? Negation. Means what result we will get? If surface area does not decreases, then the pressure does not increases. If surface area does not decreases, then pressure does not increases. Lastly, let us try to find out its contrapositive. In case of contrapositive, whatever may be the converse statement we have got, in this converse statement in both the part, use negation to find out contrapositive. So this is converse statement in both the part. If we are using not, let us see what we will get. If pressure does not increases, then the surface area does not decreases. Just simply write down it. So if pressure does not increases, then surface area does not decreases. So in this way we have got the contrapositive of this statement. Now see the last example number 4 from this question, and even last example from this exercise also. So here what is the statement? If voltage increases, then current decreases. So here the part after if we are considering as P, and the part after then we are considering as Q. Now to find out converse. Converse means what? Q implies P. Means conditional statement is there, so we have to start with if Q. Q means what? Current decreases, then P means what? Voltage increases. In this way we have got the converse of this statement. Now to find out inverse, whatever the statement is given to us in both the part, use negation. So in both the part means in P also and in second part Q also, if we are using negation, new statement is called as inverse of the given conditional statement. If we are using not in both the part, so what new statement we will get? If voltage does not increases, then current does not decreases. So what result we are getting here? If voltage does not increases, then current does not decreases. Lastly, let us try to find out contrapositive. Contrapositive means in case of converse statement in both the part, use negation to find out contrapositive. So here converse is known to us, in both the part we are using negation. What we will get? If current does not decreases, then voltage does not increases. In both the part just simply use negation. So what we will get? If current does not decreases, then voltage does not increases. In this way we have got converse, inverse and contrapositive. So simply you have to remember this symbolical representation to find out converse, inverse and contrapositive of the given conditional statement. Conditional statement means what? If two statements are connected by if, then at that time it is called as conditional statement. If once the P and Q is known to us, using this symbolical representation you are able to find out converse, inverse and contrapositive. In this way we have completed this exercise. Next part of this chapter we will discuss in the next lecture.